In the previous video and workbook, you learned how to name straight chain hydrocarbons. In this video, you will learn how to name branch chain hydrocarbons. So first, let's understand the difference between straight chain and branch chain. Here's an example. This is a 4-carbon alkane, that is butane, and the molecular formula is C4H10. Here you will see that the 4 carbons are linked one after another in a continuous chain. That is, it is a 4-carbon continuous chain. Here's another example of C4H10, and here the chain has changed direction. However, it is still a 4-carbon continuous chain. In branch chain, the molecular formula is the same, but here the longest chain is a 3-carbon continuous chain. And the 4th carbon is attached to the middle carbon. That is, the methyl group is attached to carbon 2, and this is the branch. Therefore, this compound has 3-carbon continuous chain, and 1 carbon has branched out. There are different sets of rules for naming branch chain hydrocarbons. So first, let's look at the rules for naming branched alkanes. The first rule is to identify the longest continuous chain and identify the branch, which is called a substituent. If the substituent is a CH3 group, which is attached to the longest continuous chain, then it's named a methyl substituent. Or if there is CH2, CH3, then it's called ethyl. We limit our discussion to these two alkyl substituents. So in this compound, the longest continuous chain is a 3-carbon all single bond alkane. Therefore, we say the parent hydrocarbon is propane. The substituent is a CH3 group, which is methyl. So we write the methyl as a prefix with no space. Prefix, that is, we write the name methyl in front of propane, which is the parent alkane. Then we have to state the position of the substituent on the longest chain. In this example, methyl is attached to carbon 2. So we write 2 with a hyphen in front of the methyl. And now the name of this compound is 2-methyl propane. Secondly, if there are more than one substituent of the same type, then use prefixes di for 2, tri for 3, tetra for 4, or penta for 5 to indicate the number of the substituents. Also, give the lowest possible numbers to the position of the substituents in the longest chain. So let's have a look at this example. Here, the longest continuous chain has 6 carbons, and they're all single bonds, and we write hexane, which is a parent alkane, and there are 2 methyl groups attached to it, and these are the 2 substituents, so we write dimethyl as a prefix without space between methyl and hexane. Now we have to give the position of the methyl groups. If you number the carbon atoms from left to right, then the methyl groups are on positions 4 and 5. And if you number it from right to left, the methyl groups are on carbon 2 and 3. One way of approaching it is called the lowest number rule. You add up the numbers 4 and 5, which is equal to 9, and 2 and 3, which is 5, and choose the lowest sum. So in this case, it is 2 and 3. So we write 2,3 dimethyl hexane, and there's a hyphen between the numbers and letters, and there's a comma between two letters. And so the name of this compound is 2,3-dimethyl hexane. Now, if there are two or more different substituents, then name them in alphabetical order and follow the lowest sum rule to assign their positions in the carbon chain. So if you look at this compound, the longest chain is an 8-carbon alkane. So we say the parent alkane is octane. The substituents are methyl groups, 2 of them, and 1 ethyl group. Now, alphabetically, ethyl will come before methyl. So we write ethyl and then dimethyl, and we do not consider the D of di, we consider the M of methyl in the alphabetical order. Now we assign positions to the substituents. If you count from left to right, the substituents are in positions 2, 3, and 6, which is equal to 11. And from right to left, it is 3, 6, and 7, which is equal to 16. Therefore, we choose left to right and we assign the position. So the compound is 6-ethyl 2,3-dimethyl octane. To name branch chain alkenes and alkynes, the rules are similar to alkanes with two exceptions. The longest parent alkene must include the double bond. The numbering of the carbon atoms in the chain must allocate lowest number to the position of the double bond. So in this example, the longest chain here is a 7-carbon, and it has to include the double bond. Therefore, it is a 7-carbon heptene, and the double bond is between the second and third carbons, so it's 2-heptene. And there are 2 methyl groups and 1 ethyl group as substituents. So we write dimethyl and ethyl. Ethyl will come first alphabetically, and then we give the positions, that is 4 and 6,6-dimethyl 2-heptene. In this example, the parent alkyne is hexane, and it's 2-hexane, and it's dimethyl in positions 4 and 5. So in the workbook, you'll get to practice questions on naming branch chain hydrocarbons. So good luck and enjoy.